Hello again, welcome back. We're ready for section 3, part 2, graphing polynomial factors. We're going to start off talking about something called squared factors. If p of x, the function, has a squared factor, x minus some a raised to the second power, then x equals a, whatever that a is, 2, 3, -4, whatever, it's a double root. Now, we talked about that right at the end of the last video. If a root is a double root, that is, it counts twice, then the graph is tangent at x equal a. So, for instance, if x minus 2 quantity squared is one of your factors, and you have to square it, then the graph, whatever it might look like, it might come up and then be tangent, give it a little kiss, and then goes back up. It's supposed to give it a little kiss right there. It's tangent. So let's sketch the graph of x minus 1 times x minus 3 root squared. X is 1 is a 0 and x equal 3 is a 0. Now that is a dr, double root. Alright, double root. So put one of your zeros at 1, big old dot. One of your zeros at 3, big old dot. Now, the leading coefficient is a, and it's bigger than 0. It's positive. This is a cubic equation, so it's going to finish up. All right, let's make that happen. Go up through a 0, come back down. Just give it a little kiss, whoop, and then come back up. There you go. You've got 3 zeros still. It's just one of them is a double root. It finished up because a was positive. What if you have a cubed factor? So you have a factor, but you have it 3 times. Then it's a triple root, not a double root, triple root, not tripler root. I should say just triple. It's a triple root, and the graph just kind of flattens out. It's not tangent, it just kind of flattens out around a0. So, you know, if something's a triple root, we'll just call this some point a. The graph comes up, it flattens out, and then it goes on about its merry way. And if it's negative, it just does the opposite. It finishes down. So let's try this one. Now here, a is negative, so it's smaller than 0. It's a cubic equation, so it's going to start up, come and finish down. But remember, we've got a triple root at x equal 3. Call that a TR this time. You can put triple root if you want to. Triple root. All right, so put a dot at 3. It needs to finish down this time. So it starts up, and it just kind of flattens out around 3. Stays flat, and then it changes, and then it says, okay, yep, I really do want to go down. It thought about coming back up, but then it decided, nope, I want to keep going down. That's what a triple root looks like. The rest of the video, we're just going to do a bunch of examples. Here we go. All right, number 8, again, let's see here. We've got 2 zeros here, only 1 0 here. That means that this is a cubic. The value of a, always make that note, is bigger than 0. So it's going to do one of these. It's going to finish up. It's going to finish up. X equal 1 is a double root, and x equal 3 is a single root. So at 1, put a big old dot. At 3, put a big old dot. All right, it's got to start down. Let's see here, but 1's a double root. So it's going to start down. It's going to come up, just give it a little kiss and change its mind. Whoop! Then it changes its mind again, and this is a plain old single root, so it finishes up. Sweet. All right, number 9. Oh, degree 4, so this bad boy is quartic. A, make your note, a is bigger than 0, it's positive, so it's going to do one of these. Now, it may not look like a plain W anymore because we're working on double roots and triple roots. Now, he's not factored, so let's factor this bad boy. X squared, pull it out. That's the GCF. Factor it further. X plus 5. X minus 5. It's called a difference of squares, yo. All right, X could be 0. He is a DR because he occurs twice. X could be negative 5 or X could be positive 5. So here we go. Boom, boom. Out here, negative 5. put a dot. Out here, positive 5, put a dot and put a dot at 0. All right, this guy goes up. So let's see if we can figure him out. See if we can figure him out. Well, it starts, since A is positive, the arrows face up. -5 is a single root, so he crosses. He crosses. 0 is a double root, so he just kisses. He doesn't cross. And 5 is a regular single root, so he crosses. Each time you got to decide, does he kiss or does he cross? Does he kiss or does he cross? If he kisses, he's a double root right here. If he crosses, he's a single root here and here. All right, check this one out. So here I got 3 roots plus 1 more. That makes him a quartic, yo. X could be -1, and he is a TR, a triple root. X could be 5. He is a SR, a single root. So it's just going to cross there. A, make your note, A is positive. So quartics, both arrows face up again. Both arrows face up. All right, let's check this dude out. So, -1, dot. 1, 2, 3, 4, 5. 5, dot. Okay, 1 is a triple root. Now the arrow has to start up, so start up. It's going to come down to -1, and it's just going to kind of flatten out. It's thinking about turning around. It's thinking about like, oh no, I'm just going to keep it going down. But then, whoop, I got to go back up, and he's a single root, so I just cross. I just cross. Boom. That's it. Nice job. All right, so that triple root, he kind of flattened out right there. Do you see it? He kind of flattened out. He's not tangent. He didn't kiss it. He flattened out. I'm going to flip the script on you here. Here I've given you the graph, but you got to give me the function. Now, let's see what we notice here about the graph. Well, this guy right here, it gives a little kiss. So that guy right there must be a double root. A double root at x equal -1. Let's see here. And I give you some extra point down here. Well, what's that extra point going to do? That's going to help me find the value of A. Question mark. Now notice, it finishes down. So is A negative? I think so. At least I know A must be a negative number. All right, I've got a double root here and a single root here. That means I'm working with a total of 3 roots, which means I'm working with a cubic. All right, here we go. F of x. It must be some A. Always put A first. Times x plus 1, but how many are there? Remember, it's a double root. That means it's a squared factor. And x minus 2 that's where it crosses on the right side. Okay, now we got to find the value of A. So use that extra point that I gave you right here. -3 or 3, -4. Plug in -4 for y. We don't know A. Put 3 in for x. 3 plus 1 squared times 3 minus 2. Sweet. All right, -4 equals A times 3 plus 1 is 4. Squared is 16. 3 minus 2. Well, that's just 1. So divide by 16, A is -1/4. Hey, and we said A would be negative. Now, after all that, we can write our function. F of x equals sum A, -1/4, times our factors, x plus 1, and he was a double daddy, so he squared, times x minus 2. Boom. There it is. If you want to multiply it out, you can. But don't waste your time, folks. Work smarter, not harder. Okay, last one. This one's a little bit trickier. So this guy, he just kind of, around 4, what's he do? Around 4, he flattens out, so he must be a triple root. A triple root. One arrow goes down, the second arrow finishes up, which tells me, okay, the only place I see a root is at 4. It's a triple root, and that's the only one, so this must be a cubic. And A must be bigger than 0. A must be bigger than 0. Now, on this problem, I didn't give you another point. No other point was given. So just assume A is either 1 or -1, depending on if it finishes up or if it finishes down. Ours finishes up, so A is +1. Here we go. I'm going to just use Y instead of F and X. I like to, change it up every now and then. So we have some a times x minus 4, but how many of them are there? Remember, he's a triple daddy, so he's cubed. And we're going to say a is just 1. So it's 1 times x minus 4, quantity cubed, which is really just x minus 4, quantity cubed. And if I tell you to write a function, you must put f of x. If I don't say function, if I just say equation, then you can put y. And folks, that's all I got for you. That's section 3. I hope you had fun. I know I did. I will catch you all later. I'm out.